Area experts have found that utilizing our new $10 billion toy, the flight plan could take an extremely lengthy term before it will end up being a reality. On the off chance that it goes according to plan, the visit to Proxima may expect around many years. So, all things taken into consideration, it will potentially be many years sooner than we can affirm if there can be indeed life on that planet. The deep-rooted inquiry remains. Would it be a good idea for us to say we're on our own in this universe? The James Webb Telescope has found a couple of non-human-like things some distance from Earth, driving us toward the military's reaction. Our journey for existence beyond us has been a topsy-turvy one for the span of human improvement to such an extent that we have suspended quite a large number of media works and hypotheses as we marvel at our area and isolation in the universe. This has been ordinary, as though it's pervaded within us to persistently search for a friend, regardless of how alien-like. Certainly, we ought to find more and more of the responses we care about. However, could they really be the responses we are endeavoring to find, or could they potentially be considerably more frightening as they come closer to us? As we try out the sharp disclosures in the cosmic conditions of universes and planets, we might find something we are not prepared to handle. Lighting a distant way off, scientists have figured out what might possibly be the greatest historic discovery of all time. In 2021, when the James Webb Space Telescope was planned for launch, a speculative question was raised about the limits of our advancement. The question was whether our telescopes could perceive artificial light on another planet, such as Proxima b. Proxima b, the closest exoplanet to Earth, is in the habitable zone of our nearest neighbor, the little star Proxima Centauri, which is 4.24 light-years away. Since the exoplanet is much closer to its host star than Earth is to the Sun, Proxima b is expected to be tidally locked, with a perpetual day side and night side, much like our Moon. High-level human development on Proxima b could potentially transfer warmth and energy from the day side to the night side using photovoltaic cells that produce power from starlight. In a paper with Manasvi Lingam, as one of the researchers, it was demonstrated that a large area of the day side covered with solar panels could be detected with future telescopes. Given that JWST was additionally developed, it had allowed us to expand our search for engineered artifacts on exoplanets like Proxima b. By 2024, the James Webb Space Telescope had done precisely that, using its higher sensitivity and broader capabilities. JWST should have determined the lighting installations we were looking for, potentially catapulting us into a new era of human development. Let us delve into the world of planets and exoplanets to understand how this was even possible. James Webb's main objective is to explore Proxima and its mysteries. Throughout time, individuals have pondered the nature of the universe. What are we? Where do we come from? Where are we going? These are common yet extremely difficult questions humanity has endeavored to answer since the dawn of our acknowledgement. Currently, in this time of dramatic technological advancement, one wonders if we are any closer to any of the above-mentioned questions. If you ask a philosopher, they might say we are still at stage 0 of knowing ourselves within the universe. Yet, ask a space expert the same question and watch them jump around in excitement as they rush to inform you of the most recent discoveries about the universe using their sophisticated tools. These devices, though not always of interest to the general public, are a direct indication of human development. We now have the area without difficulty at hand, and it's time we push forward and understand the universe as a whole. This has been concluded by analysts and cosmologists. Through development, we harness a particular coming of age, and this advancement is now responsible for the new discovery of what could be lights on another planet light years away. Indeed, we're discussing the James Webb Space Telescope. The James Webb Space Telescope is the result of human missions into space to address specialist questions such as, are we isolated from everyone else? Where do we begin and where do we end? This infrared space astronomy device has already begun answering those questions, though with some confirmation still required. You might ask, what even is Proxima b? Proxima Centauri b, or simply Proxima b, is sometimes known as Alpha Centauri b concerning Earth. It orbits an M-type star. Super-Earths are a class of planets that are larger than Earth, but lighter than ice giants like Neptune and Uranus. They can be composed of gas, rock, or a mix of both, with sizes ranging from twice the size of Earth to multiple times its mass. Proxima b's mass is believed to be about 1.07 times that of Earth, and it requires 11.2 days to complete one orbit of its star, compared to Earth's 365.25 days. The star Proxima b orbits emits a total brightness of around 0.16% that of the Sun. Its brightness appears much dimmer, illuminating only 0.056% of the Sun's brightness in the visible spectrum, with more than 85% of its energy emitted in the form of infrared radiation. Circling around 0.04856 astronomical units from its star, Proxima b's discovery was announced back in 2016. One might wonder why Proxima b, among the myriad stars, planets, and structures, is so significant. There are several reasons for the exceptional interest cosmologists have in Proxima b. Firstly, it is the closest star to our solar system and, by definition, to us. Although 4.24 light-years is a vast distance to us Earthlings, it is a mere blip in the grand scheme of the universe. Thus, Proxima b, our closest stellar neighbor, is high on the priority list. It is also part of the prominent stellar system called Alpha Centauri. Despite Proxima b's low luminosity, the system appears as one of the most prominent star groupings in the night sky, mainly behind Sirius and Canopus. However, the most fascinating aspect of Proxima Centauri b is its potential habitability, as it falls within the habitable zone. The potential is limitless, encompassing the star, prompting cosmologists to explore its depths and limits. This is where the James Webb Space Telescope comes in. As the JWST continues its investigation of the said exoplanet, we get progressively closer to the outcomes of these missions, from SETI to exoplanet exploration in the search for extraterrestrial life. So what exactly is SETI? Given that humans have always been a curious species, grasping and delving into everything that moves and doesn't move, it is no surprise that a project like SETI emerged on such a grand scale. Imagine that God has written a perfect grand day excursion, but with a twist. Instead of gold, we're tasked with looking for markers, particularly electromagnetic whispers from civilizations beyond anything we could imagine. SETI stands for the search for extraterrestrial intelligence, and it is our systematic endeavor to capture signs and symptoms of intelligent life lurking among the stars. Our mission has been ongoing since the early 1900s, not long after radio technology came into human use. Visionaries like Nikola Tesla and Guglielmo Marconi came up with the specific idea of using these clever devices to make an actual connection with the stars. At one point, Tesla even entertained the idea of communicating with Martians using his wireless transmission device. Fast forward to the 1960s, and we find ourselves amidst Project Ozma, the brainchild of the enthusiastic cosmologist Frank Drake. Equipped with a powerful radio telescope, Drake scanned the cosmic airwaves for signs and symptoms of something happening deep in space. Unfortunately, his efforts did not yield anything, but the mission continued, with scientists worldwide tuning their antennas to the cosmic orchestra. Meanwhile, in the Soviet Union, our counterparts across the Iron Curtain were also keen on cosmic chatter. Encouraged by notable ISF scientists, Soviet researchers turned their antennas skyward, searching for those elusive transmissions from the stars. Thus, the stage was set for a cosmic battle. But what's this? A high-quality signal received amidst the cosmic noise brought excitement and nerves to an all-time high. Named the WOW signal, it sent waves of wonder through established scientists. As the years went by, the search for cosmic partners only intensified, from SETI to the ambitious Project Cyclops. Researchers went all out in their quest to solve the cosmic mystery. Then, in a fortunate turn of events, or perhaps fate, a coded radio transmission from Mars Hill ignited interest once again. But what does that investigation look like now, and how have people advanced in these missions? Lighting installations on Proxima b were explored in a 2021 research paper titled, Detectability of Artificial Lights from Proxima b. Experts Elisa Tabor and Abraham Loeb embarked on a task to investigate the potential for detecting artificial lights emanating from the dark side of Proxima b. Considering Proxima b's position in the habitable zone of its star, the study aimed to determine whether Proxima b could support reasonable forms of life and a method for finding it. Given Proxima b's significance as a target in the search for extraterrestrial life, they developed an intriguing yet speculative detail: a new speculative radio transmission discovery from Proxima b's direction. It wasn't as recent as it seemed, given that space exploration takes light years. However, this caused a buzz among the scientific community. The tentative radio transmission added another layer of thrilling intrigue that space experts couldn't wait to explore. The transmission was identified by the Breakthrough Listen project and represented a likely candidate for an Earth-originating radio emission from Proxima Centauri, the host star of Proxima b. The Breakthrough Listen project, launched in 2015, aimed to survey the sky for signs of technological civilizations beyond Earth. In their quest to transcend the limits of space and listen for any form of communication, the project utilized cutting-edge radio telescopes and sophisticated analysis techniques. The project explored regions of the electromagnetic spectrum, searching for distinctive transmissions that couldn't be easily explained by natural phenomena. This search continued for years. The speculative radio transmission from Proxima b created excitement among astronomers and researchers worldwide. The possibility of detecting artificial lights from the dark side of Proxima b sparked imaginations and led to further investigations into the nature of the signal and its potential implications. As scientists delved deeper into the data and conducted meticulous analyses, they sought to determine whether the identified radio transmission was indeed of extraterrestrial origin or if there were alternative explanations. The implications of such a discovery were profound, potentially indicating the presence of an advanced civilization capable of manipulating technology on Proxima b. With the Breakthrough Listen project at the forefront of the investigation, researchers examined every aspect of the signal, analyzing its frequency, intensity, and spectral characteristics. They compared it against